All right, ladies and gentlemen. Did you guys hear that echo? Yeah, I think I know why. The echo because it's playing through the speakers. Anyway, I don't know. Not sure how to fix that, but it's okay. Does it kind of bother you, the echo? It's kind of weird, but anyway, let's take a look at some material here because I was thinking about it yesterday, like, man, this echo's going on. I might be able to, yeah, let's just do that. Okay, now the echo's gone. Is that right? Let's see if we still have the sound. That sounds a little normal. That sounds better. Oh, wait a minute. I hear the echo here. Now, anyway, whatever. Why is there an echo? Okay, folks, let's just take a look at this stuff here. Let's look at the website. And sounds like I'm at a baseball game. So I'm going to look at this website. And we're going to go to 241 here. Now, remember, worksheets and video library. So I'm going to share with you guys something here that's kind of on this website as we update everything. Go scroll down to, it's actually down around here, but I'm going to probably move it when I get home. We're going to work on part of these here. Okay, so this is part of what I'm going to have you guys work on, and I'm going to put that in the chat here. So anyway, so if you guys go back and look at this, some of my students maybe in the trick courses have said to me that they do go back and look at these videos. Do you guys do that too? Anybody? You guys go back? Okay, good. Do you find it helpful? Okay, good. That's the whole idea. find it helpful, you go back and you go take a look. So, ladies and gentlemen, there you go. Okay, now what I'm going to say to you guys. Remember, I said something like to you, probably one of the most useful classes you guys can ever take is this class, trigonometry. Okay, because it helps explain the world around you. So, working with, as you guys know, I sent you some, whatever that's called, I guess, extra credit on right triangle information. That's really geometry in some ways, ladies and gentlemen. And now you're dealing with law of sines and law of cosines, right? So the applications are extremely important, ladies and gentlemen. The whole reason you do this is for the applications. So that's kind of my perspective on math is there's applications of it. It's just not this sort of game like Monopoly that exists and that people just don't use it, right? People use it all the time. It's extremely important. And this is why you guys are here to do that, because it has uses. That's the whole thing about this. If you don't, look at how to use it, it almost makes things meaningless to study, in my opinion. All right, so you might say, oh, okay, how do we use this? Well, let's identify this here, okay? So what I'm going to do here now is I have this for you. Let's transition over to the iPad. And that is weird. Oh, I'm going to get rid of that. Get rid of that. And I'm going to get rid of this because this is not a part of your class. This is a part of another class. Okay? And so now we're looking at some applications. So if you guys looked at the law of sines homework, did it have applications there? Do you guys know what I'm talking about? Hopefully. Okay. Now, here's the thing. Let me see if I can scoot a bit. And no, this was in the iPad. There you go. All right, law of sines, applications. There we go. Now we're good. We're good. So let's take a look. Tracking a satellite, ladies and gentlemen. So this is kind of a tracking the satellite kind of situation where it says, if we read this, because you want to read it, the path of a satellite orbiting the Earth causes it to pass directly over two stations, A and B. And so here's kind of the story. Obviously, I put here's the what? The satellite. Here's the stations A, station B. Now, the ground, as you guys can see, is labeled here. So they have that thing labeled as the ground. And so what do they say about this? They are 65 miles apart. So the satellites here are 65 miles apart. So we want to label that. This is 65 miles, okay? So we'll start to work with some of these things. So you got 65 miles. There's a reason why we study law of sines. There's a reason why we study solving triangles. This is the reason. So we're looking down here, ladies and gentlemen, and we have this distance that's given. And that's just in the information that they give us here. Okay, 65 miles apart. And then they say when the satellite is on one side of the two stations. So the satellite was moving. I guess it's moving in this direction. And now the satellite is on one side of both stations. That's what they're saying. Okay? The angle of elevation, now you say, what do you mean an angle of elevation? Do you guys remember the definition of an angle of elevation? That's an important detail. Okay, so you say, what do you mean? Why is that so important that you have this angle of elevation and it measures 70 and 80 degrees respectively? What's the definition? Do you guys remember? You have to have an eyeball. So at position A and B here, really on the ground, you're looking up at the satellite. Is that true? Remember the definition? So the ground level here and that path, this is ground. So you can think of this as L1 and this is L2. So they don't say the satellite is moving horizontal to the ground, but in the picture it says that. So L1 is parallel to L2, okay? That means that's really an important fundamental idea. That's extremely important. They don't say that, but that's what's going on there, at least in the picture. So you got these angle of elevations given to be both, what, 70 degrees and 80 degrees respectively. Is that right? And they even indicate that. So they're telling us this is an angle of elevation. The object is a satellite. So you're looking up, it's elevated. That's an extremely important detail. And then what are they asking here, ladies and gentlemen? What's question A? Do you guys see question A? What are they saying? How far is a satellite from station A? Yeah, what are you talking about? How far is a satellite from station A? So I'm going to highlight that. I'm going to say this. They're asking for that distance. Is that true? You guys with me on this? So for question A, I don't know what you want to call that. How far? I'm going to call that D. D for distance. You guys with me on that one? That whole idea? So take a look at that. I'm reading for question A. They're saying, hey, this is how far is a satellite from position A. So there you go. That's going to be distance D. All right. Now, believe it or not, this is an application of the law of what? Science. This is why you're here, to study this, ladies and gentlemen. This is why we're here. It's not just to learn the material that is independent of an application. The whole idea is to learn it so you can apply it. That's the bottom line, ladies and gentlemen. That's where the gold is. So, okay, you might say to me, how do I know, ladies and gentlemen, that this is a law of science question? How do we really know it's law of science? Wish I had my sound effects. I got to make that a priority when I get some time to kind of bring back my sound. And I might be able to, and just have some couple of buttons there. All right, what do we think? How do we know it's law of science? Didn't we have various cases for law of science, right? If I look at this picture here, is there any angle I can find here so I can say that this is law of science? Look at that angle. Do you guys realize I can get that angle from the picture? What's the relationship? How do I know what this angle is going to be? Huh? Good. It's what? Yeah. That should measure 100 degrees. Is that true? How do we know that's 100? Supplementary. Remember that? There's supplemental. That's a straight line. So remember what we did in that first week. I think I gave you guys some of that stuff. Is that right? And that's where the geometry idea comes from. Geometry. Supplementary angles. So you might say, oh my God, Mr. Judge, they're going to make me remember that supplementary angle? Yeah. Okay. Now you say, what am I really looking at? How do I know that this is law of science? Anybody want to tell me? How do we know? Yes. Well, be careful. Be careful. Not angle, side. You're close. I understand what you're saying. There are two angles and a side, but what do we really call it? You're staring at it right here. This is really what? Angle. Sorry. What is that? What is this? Angle, side angle. Why is that an important detail? Because the side, ladies and gentlemen, of 65 miles is between two what? Angles. All right, you guys okay with that? You guys with me on this one? That is how you know that this is a law of sine situation. So law of sines is going to be a big deal. Now, this is not a right triangle now, is it? So what I sometimes have students do is they go back to right triangles and they no, that's not a right triangle. There's no 90 degrees. Remember, if this is an angle side angle situation, do you guys remember we can get that third angle easily? It's not really asked, but we may need it. I don't know. Do we need it? Oh no. Yeah, I think we do need it. Don't we need that for angle side angle? Could you guys tell me what angle is that? Right in here. Because this is where we started our adventure into law of sines. We started right here. Do you guys remember? When you get two angles, you always get the third. Isn't the sum of the interior angles of any triangle 180? So what does that have to be? It has to be 10 degrees. Is that right? You say, how did we know? Because 180 minus 100 minus the 70 degrees gives us that 10 degrees. So ladies and gentlemen, we know that this measures 10 degrees. That is necessary for us to work and find that distance. So we need this. Ladies and gentlemen, this stuff is doable. You know, I always tell students this because it's true. And I know when I was a student, I never knew this. Nobody ever told me. I had to discover this myself, right? What do you think I was doing on Easter Day besides praying to my, well, it's not a religious course, but, you know, I was praying that day. But besides that, what else? Because it's Easter, by the way, right? Yeah, I spent a little time with family, but, you know, I was working. I remember writing this letter of recommendation for a student of mine. He's a STEM student. He's going to get into this UCLA summer program. He's a very good student. But you want to know what makes him a good student? He started in elementary algebra. You want to know what makes him a really good student? You want to know what makes me really impressed by this kid? Yeah, I had him for Calculus 1 and Calculus 2. And this guy is, how should I put this? He understands how to do things. You say, what do you mean? He has that strong desire to succeed. So he does his work. He follows up. You know, he does what he's supposed to do. He does everything he's supposed to do. This kid is fabulous. So, you know, I need to write a letter of recommendation for a summer program. You think I'm going to spend my Easter writing that letter? Absolutely. You guys see what I'm saying? You don't stop working. That's my point to you guys. You don't stop. It never ends, even on Easter. It's a matter of, what did Jaime Escalante call that? Do you guys know what he called that? It's very simple. It's called ganas, desire, will. And if you have that, you can do anything. Will. Get that will. He has that. So that's what I put in the letter. I actually put that stuff on my Easter break. It's all good. So, okay, ladies and gentlemen, do you guys want to get that will? How do we get that will? That's the secret. How do you get that will, ladies and gentlemen? Do you guys know? I don't know. For me, I just decided to do my homework every day. I said, you know what? I'm tired of fooling around. I didn't play with Xbox. We didn't even have Xbox. Sony PlayStation. Just said, you know what? I'm going to do my homework every day. That's what I'm going to do. Tired of, fooling around. So this is how this kid is. He's an amazing kid. All right. What does law of sines say? Do you guys remember? Don't I have opposite right here? Let's do this here. I have an angle and I have an opposite side. So what does that mean? Sine 10 degrees over what? 65. What does that equal? Oh, I have an angle and I have an opposite side. That is sine of what? 70 degrees over what? Over D. Do you guys remember doing some of that for homework? Cross multiplication? Do you guys remember that? Proportions? How does that work? Right? Remember, this is going to be D now. Sine 10 degrees becomes what? 65. Sine 70 degrees. What happens now here, ladies and gentlemen? Sine of what? 10 degrees. Sine of what? 10 degrees. That goes away. What does your D become? Right? So I'm going to cancel that because it went away. We canceled that. So there's our D, ladies and gentlemen. What does that give you? We're going to have to get out the TI calculator. Mode, look for degrees, okay? Are we in degree mode? You guys know what might happen one day? You're in the wrong mode of your calculator. We're in degrees. Okay, we're going to hit what? 65 sine of 70 divided by sine of 10. So what is this D going to be? Do you guys know? Let's go out to the nearest whole number. Is that 352? Okay, 352, ladies and gentlemen. Right? We entered this in the calculator. We made sure that it was in what? Degrees. So 351.7 is about 352 miles. Ladies and gentlemen, there you go. There it is. So we know that that distance is 352 miles. So ladies and gentlemen, let's get rid of all of this distraction here, okay? So we just found this to be this distance, 352 miles. This distance right here. And all because we know law of what? Sines. Easy peasy, lemon, what? Squeezy. All right? All right, what does this next one say? You guys see that? What's question B? What is the altitude of the satellite above the ground? So, we have to talk about this stuff because, sometimes people might even say, hey, Mr. Judge, what do they mean by altitude, right? What do you think they mean by the altitude of the satellite? What is the definition of altitude? It's like, it's not just, well, yeah, it is height, right? But be careful about this because I was one of those kids who I was like, what do you mean by height? You know what you mean by height, ladies and gentlemen? That was me. You know what they mean? See if I can draw this here. This here is the altitude. I'll call that A. Okay, and I'm going to move that 352. This is 352 miles. There's your altitude. You want to know what I need to do, though? I want to make very clear about altitude, some very important fact. You know what it is? That this is a corner. You see, if you ever want to know about altitude, it is a strictly vertical height. Do you guys know what I'm saying? Vertical. It's not a diagonal. We just found a diagonal. 352 was the diagonal. So you might say, well, what do they mean by an altitude? It's a vertical height. So this is an important detail. Why do I want to point this detail out? What does that mean? That means this is a what? 90-degree angle. Is that right? Why is that important? Because they're asking us for the what? For the altitude. This is A now. So question 2, or B in this case, is what's the altitude? So they're going to want us to have that height. Ladies and gentlemen, why did Mr. Judge do that assignment over spring break? Well, 2 reasons. I think it's unacceptable to people to not know how to solve a right triangle. It's unacceptable. That's how I really feel. Unacceptable. Not only that, second reason is because take a look. I use these things. We use these things to get answers. I can use my right triangle information, ladies and gentlemen, to do what? To answer this. What do I mean by that? Let me get rid of this. Do you guys happen to see a right triangle anywhere? I see one. Do you guys see it there? Look at that. What am I going to use to find the altitude? Anybody remember? What is it? What do I use? You guys did the assignment. It's going to be what? Right? I'm going to have to erase this. So it's in the video. I wish I did something with this. So I'm going to have to dig this out. I wrote this years ago. Anyway. What do we use? What's the definition? We have the angle 80 degrees, right? And then we have what? Opposite hypotenuse. Oh, isn't that sine? I'm not awake yet. Sine 80 is A over 352. So in other words, I just go back to geometry. A right triangle. And can I solve for A? How do you solve for A? What does A equal? 352 sine 80 degrees. So, ladies and gentlemen, this is why I did what I did, because I do know you're going to have to use this to do an application. Meaning 352 sine of what? 80. And guess what I'm able to get, ladies and gentlemen? Now this is the altitude. What's the altitude going to be? Let's go to the nearest whole number. That's 340 what? Let's go to the ones position, right? The decimal to the right is a 6. What does that mean to do to the decimal to the left, which is also a 6? Add 1, and what do you guys get? 347 what? Miles. That is your altitude. So, ladies and gentlemen, we have used right triangle information. 347. We should put miles. I just want to let you guys know it's miles. We use right triangle information to find the altitude based on a couple of measures. So based on a certain amount of measures, we can deduce altitude. And that's how, this is why you guys are here to do this in a trig course. It's kind of like a major idea behind trigonometry. So when you go to other classes, you know, that have a prerequisite of this material, there's an expectation. You guys know law of sines, law of cosines, and how to do these applications. That's the expectation. Because now what you're there to study in some of those other courses is actually how to use these things. That's the whole idea. This is why we do what we do. So I'm a person, if you guys notice, you say, boy, that Mr. Judge, he does work on applications. Yes. Why? Because I know where you're headed, you use them. That's the whole idea. And yes, you might want to get used to this idea. Like I'm saying, you never stop working. It just doesn't end. I used to, as a kid like you guys, I used to think, oh, one day I can't wait to stop working. I'm still waiting for the day. That day hasn't came. Even on Easter, writing a letter of recommendation. Between praying, spending time with family, I got to knock out that letter. Doesn't end. So embrace it. Get used to it. What do you guys think? Isn't that everything we worked on? I think so. Did Coach ever do that kind of stuff? No? What did Coach do? Just throw the ball around in the classroom? Just hang out with everybody? Give everybody a high five? At least give people Flamin' Hots or Snickers? Man. Should have been Coach. Darn it. Yeah, it's funny. You know, it's kind of interesting. I used to bring my daughter. My daughter, when she was a little girl, I mean, back then in the day that we're talking about, it's a different time. You know, students would come in on a Saturday. They'd want you to come in on a Saturday to help prepare for a test. They would like say, "Oh, Mr. Judge, can you please come in on a Saturday? We're gonna have this test." And that was common back then. This is like 20 years ago, ladies and gentlemen. Times have changed. And so you'd come in, you know, and then sometimes, you know, to have my daughter sit there because, you know, who's going to watch her on a Saturday? So I'd bring her in. She'd sit there and she would just watch, you know. She learned how to take notes. That's how she learned how to take notes, just coming with me on Saturday when I'd lecture. And so she just got into that habit. It's weird. It's weird how you pass that stuff on to your kids. You know, so she was taking notes. She used to bring her in. You know, so she learned all those little things. And then some lectures I'd bring her in, not even on a Saturday, but some lectures. And if I was like a two or 3 minutes late or 5 minutes late for a lecture, you know what would happen? And I walk in the room with my daughter. You know what you would hear? You hear this sound like, oh, meaning, oh, he showed up. And my daughter was like, Dad, why did they react that way toward you walking in a room? Oh. So I explained to her, well, sweetheart, no, it's not that they resented your dad being there. It's just, you know, they thought they had a free day and they didn't. I don't know. I think that's a funny story personally. So she learned this. Oh, it's funny. I don't know. Interesting. Here's another one of my favorite examples, ladies and gentlemen, the flight of an airplane. That's very, very similar to what this was. Very similar questions. They're all applications for law sines. And then we'll see law cosines. So here's the deal for flight of an airplane, right? And I know that it's an extremely important thing to read through it and even see the picture. Because sometimes there's details they don't even tell you as you read, and you want to talk about those details, right? Like, for example, the flight of a plane, they don't tell you that it's flying horizontal to the ground. They don't tell you. So here's what they say. The flight of a plane, they're saying a pilot is flying over a straight highway. They just say straight highway. And you go, what do you mean by that? All they mean is that the flight path here and the ground level here, two lines again. Call it L1, L2. These lines are what? These are parallel, ladies and gentlemen. That's what they're saying. So they don't even say that, and I wish they did, but okay, a pilot is flying over a straight highway. Okay, there you go. And you know, the reason why I put this phrase horizontal, because that's related to a couple of things, but I just want to communicate to people that those are, or horizontal is parallel there. He determines, or she determines, the angle of depression. Now, when they use the phrase angle of depression, what are they talking about? Because that's an extremely important detail too. What's an angle of depression, if you guys remember? The definition of which? If it's an angle of depression, your eyeball is above the object. So this is the eyeball of the pilot. So now the pilot's eyeball is there. And now you need an object. And you say, what are the objects? To two posts. When I read this, I'm like, what's a post? I don't know. What's a post anyway? It's just like an object, I guess, on a highway. So in other words, you got two posts, and again, here, the pilot is looking at post A, post B, two posts, and the pilot says they're 8 miles apart. You go, oh, so this distance is what again? 8. You guys with me on that? So the pilot is going, okay, I got two posts 8 miles apart, and you got these angle of depressions that are 35 and 46 degrees respectively. So remember the definition. Horizontal, we already have labeled. To the object, that angle is 35. The other is 46. So you're not free to put your angles anywhere you want. The definition of angle of depression and angle of elevation is in play. Remember, in both cases, you need a horizontal. You need an object, you need a horizontal. And it's the angle between the object and the horizontal. And so you might say, oh, what is that? Well, here's the object between, here's that line, because your eye sees things in a straight line. So this is why we know it's 35 degrees, it goes there. And this is why we know over here, between the horizontal and that line, it's 46 degrees. So the picture is consistent here. And I'm going to make the claim here, ladies and gentlemen. This is, again, law of sines. How do we know it's law of sines? What situation do we have for law of sines? Remember, if you go back to our law of sines work, law of sines, where are you? Okay, law of sines. We got side angle, the ambiguous case, that was law of sines. Go back from the beginning. All that work we did. I think I have it way up here. We have it here. Where is it? Oh, here we go. It applies to what situations, law of sines? Angle, side angle, or side angle. This is the essence of law of sines. So what I'm saying is, how do I know that this application question is a law of sines? Because it's not clear. It's not clear. What are my angles? You guys say, but the angles are outside the triangle. Let me change my colors. Green. What's this? Orange. I'm going to change those colors. You know what I'm going to make the claim is? I know what this angle is. It's green. I know what this angle is. It's orange. But my question to you is why? How do I know that? Now, there's a reason. And we actually worked on it. There's a very good reason, ladies and gentlemen. Let me do this. What are you really looking at? Here's something here. What are we really looking at here? Oh, that's weird. What is this? Isn't this another line? But why am I using all of this important detail? What is this really? It's a transversal. Yes, that's the whole idea. So the stuff we already worked on is right here. You remember that? A transversal? So what this says to me is that this is 35 degrees. And in fact, if I say, okay, there's another line here, that means that this has to be what? 46 degrees, because we're looking at two transversals on top of each other. So this is transversal information, if you guys remember. Did we work on transversals? Yes, transversals. So why does law of sines come to mind? Because notice the question they're giving you now, right? Let's get rid of all of that. What do they want to know? The first question is, what is the distance of the plane from point A? This is what they want to know. This is D. Because the plane is here, point A is here, So for question A, we're labeling that D for distance. What kind of situation are we really looking at? Now we know what it is. What is this? Because you got to identify that. If you don't identify the situation you're in, you're not going to know whether you use law of sines, and you haven't looked at law of cosines yet, but we will. This is angle, side, angle. Good. How do you guys know you have angle, side, angle? Angle, side, what? Angle. So do you guys think that's important work to do, the angle, side, angle? It's very important. This is what's done, ladies and gentlemen. This is how you do this. Okay. So law of sines comes into play. Anybody have any questions on what we just did? We're using transversal information. Here, earlier, we used supplementary angle information, that straight line, supplementary angles. And then we used a right triangle. So this is what's going on. This is a study of triangles, ladies and gentlemen. So, okay, what can we say? What is needed for angle, side, angle? Don't we need another angle? What's this angle right in here? Anybody know? What's that angle? How do I get that angle? Isn't that 180 minus 35 minus what? 180 minus 35 minus 46 degrees. Okay, so let's do that. And, oh, it's 99-degree angle. All right. There we go. Now we could use law of sines. Is that right? Remember, angle, side, angle, you get that. I'm sorry. Yeah, angle, side, angle, you get the third angle. All right. Okay, folks, let's try this out. What does that mean? That means what? Sine 99 degrees over what? 8. What does that equal? Sine 46 degrees over D. Does anybody remember why we do that? Because we have an angle and we have an opposite side. That's how law of sines works. And then you have an angle, and then you have the unknown D. So we got 3 knowns, 1 unknown. That's going to allow us to solve. That is the law of sines. You guys are looking at it right there. So how do we apply it? Do you guys remember? Cross what? Multiply. D. Sine 99 is 8. Sine 46. How do you guys solve for D? Sine 99, divide that from both sides. Okay? Cancel, and now D becomes 8 sine 46 degrees over sine of what? 99. Let's see what D is approximately. Let's get that out, okay? And you get your TI now. Okay, TI, here we go. So here's the deal. 8 sine 46, close that, divided by sine of what? 99. What do you guys end up with? Let's go out to the nearest whole number again. I feel like in the whole number mode. 6. Was this stuff in miles? Yeah. 6 miles. Okay. So, ladies and gentlemen, we got 6 miles here. We found that distance. It's really 5.8 or something, but we're going out to the whole number. Maybe we'll go out to the tenths. I don't know. On a test, I'll tell you what to approximate probably. And ladies and gentlemen, there it is. Easy peasy lemon squeezy. right? If you remember transversal. All right, let me erase this here because take a look. What's the next question? Do you guys see the next question? Yeah, it says find the elevation of the place. Jesus. Of the what? Of the plane, not the place. How do you think what do they mean by elevation? What's the elevation again? Do you guys remember? It's a vertical line. That means this has to be 90 degrees. This is A for elevation. So the next question in B is to find the elevation. I call that A for elevation. So I'm going to get rid of this, and I'm going to remind you guys here. Now you have a way to find a vertical distance there, the elevation. How do you do that? Does anybody know? Do you see what I see? What do I see? Do you see a right triangle? Do you guys see a right triangle? So how do you use that right triangle now? I'm going to erase our law of sines because we don't have a lot of space. Yeah, what's the definition? Do you guys know? Sine of 35 degrees. What does that equal? Opposite over hypotenuse. Okay, that's why we did that stuff. Where's that coming from? Is that me? Did you guys hear a noise? Sounds like email, but I don't have my email. I don't have my email on. So what is A going to be? A is sine 35 degrees. Is that right? So not A is 6. 6 sine 35 degrees. Close that up, ladies and gentlemen. And, it's, you know what? I don't feel, whatever. I should have been more accurate, but we'll go with this, okay? I apologize. I would rather have been more accurate, but it's a very crude computation. So, okay, E is about 3 miles if we go to the nearest whole number. On a test, I'll say like the tenths at least. Okay? So, altitude's about 3 miles. It's actually not, but okay. Very crude, but you guys see the point. You can now adjust your accuracy any way you like. These are all approximate. So, ladies and gentlemen, this is how we apply what we've learned. Okay, these two very, very relevant and important examples is how you apply what we've learned here. Height of a tree, calculating distance of a balloon. Oh, this is another one of my favorite kind of things. Here's what I'm going to do now, ladies and gentlemen. Okay, I'm going to do a little transition. I wanted to share with you guys how to do a couple of those things here. I don't want to get too ahead. Okay. I think we call that A, B, C. Then you have this little a, little b, little c. Okay? Now, if I go back to I'm going to take a look online here. 241, let's see the browser. Worksheets and videos here. I do have a worksheet, and of course you guys have that bookwork. Law of cosines, right? Do you guys see that there? Law of cosines. So here we have angle, side, angle, and side, side, side. So I want to share with you guys here, this is what I kind of wrote down for you guys. This is, again, law of what? Our law of cosines here. Let me double check. Yeah, okay. So when I go to the iPad now, I want you guys to remember when you have a case called angle, side, or side, side, side. We get to use what's known as law of what? Cosines. Going back over here to the browser. It's these formulas. Now, I want to illustrate to you guys really how to memorize this so that you know how, but there's an easy way to use it. Okay, yes, you might say, oh my God, what does this formula look like to me? Okay? What are they really saying in these formulas here? All right. It's a bit like Pythagorean theorem. You see, let's say, for example, you have angle, side angle. And what does that actually mean? Angle, side angle. So if, for example, you have, what? Angle. Oh, I'm sorry. There's something bothering me about this. What's bothering me? It's not. It's side. It's a little dyslexia. It's actually side, angle, side. I apologize. Okay. No wonder it didn't make sense. I was like, wait a minute, this is law of sines. Okay. So here's what I want you guys to see here. Okay. Law of cosines is going to apply for side, angle, side. What does that side, angle, side mean? Yes. Oh, you guys can't. Oh, this is. Oh, I apologize. There we go. Sorry. Say, what's going on? Okay. There we go. It's when you have side, angle, side. I apologize. Or side, side, side. So we're going to focus on the side, angle, side for you guys, right? And notice what I mean. Here's side. Here's what they're saying. What if you have side B, angle A, side C? So the angle is included. This is called an included angle. And this angle is between two adjacent sides. So you say, what angle? Well, A. A is between two adjacent sides, just to let you guys know. So what's really going on in this formula here, it's kind of like Pythagorean theorem. You see the opposite side A there? Okay, you guys with me on this? I want you guys to focus on that little side A. Here's what I mean by that. What law of cosines says, if you go back here to law of cosines in the browser, they're really talking about, let me scroll down, the second line here. Because you say, Mr. Judge, how come they have 3 versions? Yeah, there is 3 formulas. But let me simplify it for you guys, okay? So I'm really talking about the second formula, but I'm going to simplify this because it's actually a real easy thing to do. If we kind of think about, Pythagorean theorem. Here's what I mean by that. You have the side angle side situation. Okay, you see A that's red there? Law of cosines really means this. If you know one, you know the others. Take that A squared in red and then take the two remaining sides. So this is what I mean. It looks like it's Pythagorean theorem. But be careful. This is A. Okay, that's unknown. And it's A squared. And then you got B squared and C squared. Those are known. All right, for side angle side. And then you say, well, what else is there? Well, it's minus 2BC. In other words, it's not Pythagorean theorem. There's more to it, 2BC. And then you say, well, why do they call it law of cosines? Because you're going to have now cosine of what? The angle A. So everything here on the right side is known. I might prove it to you guys tomorrow, show you guys where it comes from. But it's a very simple formula to apply. It looks complicated, but you got to use your calculator. Now remember, this is side angle side. This is what I'm saying. We're focusing on this situation. Side angle side. Okay? It always gives us a way to find that opposite side little a. This is the law of sines formula here. Law of cosines. It's a very simple pattern. We're looking at the pattern here. So if you said to me, okay, Mr. Judge, let's do this here. What if they gave us side angle side again? You said, what if they gave us two sides and an angle? Now they gave us a, little c, and then big B. Right? We're going to deduce again this formula here because you have three formulas. But you really only need to know one. They're going to ask you again for the remaining what? Little b. Okay, in red. So law of cosines will say what? Start with that little b. This is how I remember it, ladies and gentlemen. Start with this little what? B. And square it. Start with the opposite side of the angle. And then what are the two sides that are given? They're given A and C, right? So this will be now A squared plus C squared. Because those things in blue are given to you guys. And what happens is this is going to be minus 2B, not 2AC. The sides that are given, everything on the right is given to you in blue. And now this will be cosine of big B. It's, again, opposite the little b. So everything in blue is going to be given to you guys, and this is known as the law of cosines. It's going to enable you to find that side little b. Easy peasy lemon squeezy. It's a way to think of this formula here. So this is always, again, when they give you the situation of a side, angle side. Yes?
So the first one was if they give you a side, angle, side.
They're all three of these that you see here, we're going to do three, are side, angle, side. So all of these are this first case, side, angle, side. But I want to share with you guys how to look at the formula and how to use it. So notice now, I'm going to do another one here. Here's what I'm going to do here. What's given to you, again, is in blue, side, angle, side. So if they give you side, angle, side, opposite the angle is little c. It's a formula that's pretty simple to do. So again, they gave you side, angle, side. All of these are side, angle, sides, where the angle is between two adjacent sides. So c squared, that side here, ladies and gentlemen, is going to equal, you say, what is that going to equal? What did they give you? What are the two sides they gave you, A and B? So what is it going to be? A squared plus what? B squared. And then don't forget minus 2AB, those same sides. And that's going to be cosine now of angle C. So that's opposite, the opposite angle to side C. So notice again in blue, this is the pattern for the formula. It's a very simple formula, but you know, it has some things to think about. This is called law of cosines. And you know, we can prove it, but not today. But we're going to use this here. Just going to get something up and running here. Oh, come on. Okay, so ladies and gentlemen, let me show you guys how to use this as an example. These are your law of cosines formula here. So we're going to start simple. $38 meters. That's 38 meters, and then maybe 21 meters. And then you have to have a what here? Right? We're going to have an angle that's what? Anybody know what I'm talking about? We're going to work on the side angle side situation here. Okay? Now, just for simplicity's sake, we'll say A, we'll say B, and we'll say C here. So that makes this little c. You know what they're going to ask? They're going to say, what is little c? So here's my point to you guys. Side, angle, side. They're going to always want the opposite what? Side here. Notice they ask, what is little c? So how do you go about this, ladies and gentlemen? What do you think you do? What do you say? Little c squared is equal to what? How do you do this? What were the given sides? 38 squared plus 21 squared, okay? Minus 2 times 38 times 21. Times what? Anybody want to tell me? This is law of cosines. Cosine of what angle? Which is 80 degrees, is that right? They gave you these things. This, 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 this. We'll see. So you now say they want c, not c squared. You guys know what you do? What is c then going to be? Do you guys remember the square root formula? You take the square root of what? All of this. And I know you might say, Mr. Judge, isn't that plus or minus? Well, it would be, right? Do you guys remember the square root? Didn't we work on square root formula too? You say, wait a minute, we did square root formula here. Okay, what do you do with that? Why do we get rid of the negative? Anybody remember? Because distance is not negative here, right? You don't have negative distance for C. So what I'm saying to you guys is this can be very, very easy to do when you have your calculator here, right? And we'll be using our calculator for this. So you say, okay, well, how do we use the calculator? Here we go. That's going to be, remember, second radical, what's this? 38 squared plus 21 squared minus 2 times 38 times 21 times cosine of what? 80. It's 80 degrees. Okay? So double check, ladies and gentlemen. I entered everything here the way it's supposed to be. What do you think happens when I hit enter? We're going to go out to the nearest whole number. What is this going to give us? Isn't C going to be approximately what, 40? Come on. And there you go. This is by law of cosines. And very often, they're going to want you guys to actually do that here. So if I said to you, now, what is angle A? How do you guys think you could get angle A? Right? I'm going to remove this here. No. How could you get angle A? Well, there's a couple of ways you could do it. There's a couple of ways. How would you get angle A? I mean, you answered the question. They want you to find that from side, angle, side. They want you to find the opposite side of C, the opposite of the angle. It's a very common question. Very common. You could use law signs. Or note. Let me share with you guys another thing. Right? Isn't it true the formula for little a squared is b squared plus c squared minus 2bc cosine of a. So what your book is going to have you guys do here is solve now. And if I said, what is A? Let's color that red. Yeah, it is red. What is the angle? Here's what your book is going to suggest for law of cosines. Because everything else is given to you. Is that true? Can you solve, first of all, this? I want you guys to do this. Can you solve for cosine A? The answer is yes. How do you guys solve for cosine A? Do you guys know a quick and easy way to solve? You guys know what this is? If I move these lines, who knows what this is? It's called translation, moving terms. So if you move terms from the opposite side of an equal sign, right? So what I do to quick and easy solve is on the left side, 2bc cosine A, I'm going to quickly solve this, is positive. So if I move a term, you say, what terms did I move? I moved this term. I want to get a highlighter in gray. I moved this term over here. I moved the term on the right to the left. What happened to the sign? It changes. It's opposite. I moved the a squared term to the other side. What happens to its sign? It's opposite. Here's my point. Look at the signs now. They're opposite. Okay? It's called translation, or you add them to each side. That's all you're doing. It's shorthand for adding or subtracting a term. So now I can solve for cosine A. What's cosine A? Right? Divide both sides now by the 2bc. Just using algebra. And then what happens here? Cosine A becomes what? B squared plus C squared minus A squared, everything over 2bc. This is by law of cosines, ladies and gentlemen. This is going to enable you to find angle A. This is what the book says you can do. The book wants you to have this version of law of cosines. So that you might say, now, what does this mean for me? Well, it means cosine A, remember, everything on the right here is going to be given to you. So it's in blue. So if I go back and I say, I need to know what B and C are. You say, what's B and C? Oh, okay. So this will be B, this will be C. Is that true? So B and C, 38 and 40 here. Okay, 38 and 40, B and C. So 38 and 40. So, oh, what is that? Okay, let's be more specific. Little b is 38. Okay. So we say, okay, that's 38 squared plus 40 squared minus, what's that little a? We just found that, I think. Yeah? Little a is 21. So it's minus that 21 squared over 2 times that b and c. So it's 38 times 40. So what I'm reminding you guys is simply this is going to be there. Now, it gets better. Anybody know, what do I want to do with this now? Because I need angle A. I'll tell you what I do. How do you get angle A? You're going to have to use what? I'm going to put this in red here. Use inverse what? Cosine. We might have to do a whole bunch of inverse sine, inverse cosine things. Inverse functions. You guys remember inverse functions? I think we might have to do a little worksheet on that. They'll do a little S on this stuff. What do I mean by inverse cosine? You have to do some S on inverse cosine. Doesn't this mean that A is inverse cosine of all of those numbers that we have here? You guys know what I'm saying? This is what the book wants you to do. If you look at that book on law of cosines, your book is going to go through this detail, inverse cosine. So we might have to do some S. How do we get inverse cosine, inverse sine? There's even inverse tangent. We'll see that in our future. But the point I'm making here is this is how we get angle A by law of cosines, using a little bit of algebra. So when you go back and look at the example of the book and you go, How come they have all of it this way? Well, second inverse cosine, that's blue. And you know what I do is I'll put a parentheses for the numerator, work. So 38 squared, look at that parentheses here, plus 40 what? Squared minus 21 what? Squared, and you close that. There's my numerator here, right? And then you have divided by what? Parentheses again, 2 times 38 times 40, and then you close that too, but you got to close it twice. So I want you guys to go back. Let's take a look at the iPad, and we're going to look at this calculator again because it's an important detail. We put this numerator here in another set of parentheses. We put the denominator here with another set of parentheses here. And yes, this is inverse cosine. So let's take a very close look at the calculator. Okay, so I'm going to take a close look at that calculator and have you guys double check. Maybe I could go back here. Right? Is this inverse cosine? Yes, it is. So notice that I have a parentheses already for the inverse. Then I have the numerator in its parentheses. Division, that's divide by the product in the denominator in a parentheses. And what do you guys get? What's the angle? If we go out to the nearest angle, what is this going to be? 31 degrees. Ladies and gentlemen, I guess that was red. It's now blue. We know what it is. Angle A is 31 degrees. So this is known now. This is using law of what? Cosines. And guess what you can now really do? Now we can find what? Angle B. How do I know what angle B is? 180 minus 80 minus 31 degrees. I can get the remaining what? Angle with the fact that the sum of the interior angles for any triangle is 180. So you say, well, what's that going to be? Well, let's take a look. 180 minus 80 minus 31, 69 degrees. So this is the approach that you use via law of cosines. And ladies and gentlemen, you're still able to solve a triangle, but this is what's called side angle what? Side. So whenever you have side angle side, this is going to be the procedure that you what? That you use. Right? You guys see what I'm saying? So if I look back here online here, and let's look at this here, assignment here, right? Where are you guys at? Let me get that here. Browser, we need browser. Yeah. Oh, there we are, browser. Okay. I have some homework on law of cosines and some homework on law of sines. 6.4 and 6.5. It's already listed there for you guys. So we're going to continue our work tomorrow. I think we might do some S tomorrow, and starting in the morning, where we start using our calculator inverse functions. So you guys can start to become very good with what? Inverse functions, and we'll continue with law of cosines. We'll continue with applications. But you may want to start to work on finding what? Solving these law of what? Cosines as well. So if you're that student that you say, no, I do this the night before, the weekend before, is that a good game plan? I would say what? Nope. Not a good game plan, ladies and gentlemen. When do you want to start work on this stuff? Now, as soon as possible. Okay. Take care and stay safe. We'll see you guys tomorrow.